How do wind turbines spin?
Wind turbines. Giant, glorious fans that spin and magically convert wind into electricity that we can use to give us light and toast bread. But have you ever wondered how the hell wind is able to spin these giant wind turbine blades? Not only that, but look at this.
Have you not noticed that as wind blows into the wind turbine, the blades turn clockwise, perpendicular to the direction of the wind?
Like what? That's why today I'm going to answer this question. How do wind turbine blades spin?
Hey, did you know that the blade of a turbine is designed just like an airplane wing? As wind blows into the blade or wing, a force called lift is generated. And if you look at the cross sections of the blade and the wing, see they are both made up of these whale shapes. This is called an airfoil, and we'll be looking at how this generates lift. So, here's our airfoil. One main theory to explain how lift is generated is flow turning. Basically, as the airflow strikes the wing, the top airflow goes over and it kind of sticks to the surface. Then it leaves the wing at a downward direction. This also deflects the bottom airflow down. Since air above the wing is guided down and air below the wing is also deflected down, we get a downward force, and we can represent it with this vector. Since air also slows down, we also get this. If we combine these forces, we get air deflecting down in this direction. According to Newton's third law of motion, for every force there is an equal and opposite reaction force. So here you would get an opposite force pushing the wing up and back. Lift. Lift is what lifts an airplane up in the air, and it's also what moves the turbine blade. But what if we want more lift? To get more lift, we can increase the angle of attack like this. This slants the wing and makes it direct air downwards at a sharper angle. As a result, we get a stronger downward force from the air and we get more lift. But what happens if we increase the angle of attack too much? If we increase the angle of attack too much, the top airflow will stop sticking to the surface and it will no longer be guided down. Without the top airflow going down, the bottom airflow will also stop going down a bit. If this happens, the airfoil stops producing lift, and this is called stall. If this was a plane, it would just drop out of the sky. So now we know how an airfoil generates lift. Now let's go back to our wind turbine. To visualize the forces that spin the blade, we'll look at a top-down view. First, this is the front view of the air turbine, and it turns clockwise. You want to look at it from the top here. This will be the body of the wind turbine, and this airfoil here is the turbine blade. It's kind of confusing, right? Pause here for a second to process this. Now, if you understand this diagram, we can start to look at the forces. As the turbine blade rotates clockwise, air strikes it like this. This is just like what we saw before. But this time, there's also wind blowing from the front of the turbine. And since the force of the air is greater than the wind, this vector is a bit shorter. Now, what happens when we combine these forces? You guessed it, we get this force. And this is called apparent wind. So now, let's apply what we learned before about airfoils. Since we can roughly say that wind flows like this and air slows down, we get a downward air force that's almost perpendicular to the apparent wind. As a result, we know we get the opposite force, lift. Lift will have a horizontal force kind of like this, which is called the torque force. This is what rotates the turbine blade.
Haha, look at it spin!
So, there you have it. Today, we learned how a wind turbine spins and the forces involved. Let's just quickly go over the key points. So, first, we learned a turbine blade is made out of a set of airfoils that look like whales. Second, we saw that as wind flows into the airfoil, air gets deflected down, and this generates lift. If the angle of attack is too big, we get stall, and lift goes bye-bye. Third, we looked at our wind turbine from the top, and we can see that apparent wind comes from this angle. As a result, we get the same deflection of air to produce lift. Finally, we get torque, which is what spins our glorious wind turbine. It's amazing how when we break down the forces into little arrows, we can show how something like a wind turbine moves. Now, time to enjoy some good old toast. Damn. Thanks for watching!